Working of a transistor. That means we have to explain the working of NPN transistor. Now we can draw a diagram of NPN transistor. NPN transistor has three terminals. NPN transistor has three terminals, and here P-type base is sandwiched by N-type emitter and collector. E is the emitter, B is base, and C is collector. And here P-type base is sandwiched by N-type emitter and N-type collector. These are the conduction electrons and holes. Now, in N-type emitter, majority charge carriers are conduction electrons, and this majority charge carriers, conduction electrons, are denoted by dot, and holes are the minority charge carriers, which is denoted by circled positive sign. And on the right hand side, in N-type collector, in N-type collector, majority charge carriers are conduction electrons, and circle positive sign are the holes in N-type collector. Similarly, in P-type base, holes are the majority charge carriers, and dot means conduction electrons are the minority charge carriers. And this element is known as emitter. And on the right hand side, the longest part of the transistor is the collector, and the middle portion is known as the base. B is base, E is the emitter, and C is the collector. Now, emitter is forward biased with respect to the base. Emitter is forward biased with respect to the base by connecting an external battery of EMF VEB, and in this case emitter is always forward biased with respect to the base. That's why N-type emitter is connected to the negative terminal of the external battery VEB. And on the right hand side, collector will be reverse biased. Collector will be reversed biased. Collector will be reverse biased, and in this case N-type collector C will be connected to positive plate or positive electrode of the external battery VCB. Here we are connecting an external battery of EMF VCB, and here VCB is the EMF of the external battery, which is connected to the collector with respect to the base. In this case, N-type collector is connected to positive plate of the external battery VCB. In this case, conduction electrons, which are the majority charge carriers in N-type emitter, will be repelled towards the base, and the minority charge carriers in N-type emitter, that is holes, will be attracted by the negative terminal of the external battery of EMF VEB. In this case, that's why as holes in emitter are flowing away from the emitter, that's why emitter current IE will flow away with respect to the emitter. Now the conduction electrons, that is majority charge carriers from N-type emitter, will migrate into the collector through the base, and this conduction electrons will recombine with the holes, that is the conduction electrons coming from the emitter will recombine with the holes, that is with the minority charge carriers of collector. Now majority charge carriers of N-type collector, that means conduction electrons will be attracted by the positive terminal of the battery VCB. That means conduction electrons, or that is majority charge carriers in n-type collector, will be flowing away with respect to collector, and here the holes, that means minority charge carriers, will be moving towards the base. Here holes will be moving towards the base, and when conduction electrons, that is majority charge carriers, migrating from n-type emitter recombine with the holes, that is with the minority charge carriers of n-type collector, it will produce collector current IC. It will produce collector current IC. Collector current IC will flow into the collector. Collector current IC will flow from positive terminal of the battery VCB towards the collector. Here, that's why collector current IC flow into the n-type collector in NPN transistor. In NPN transistor, similarly, we can say that in what way base current will be produced, and base current IB will flow into the p-type base. Here IB is the base current which flow into the base, and emitter current IE will flow away from n-type emitter. Emitter current IE will flow as IB and IC into the base and collector respectively. IC is the collector current here, and IB is the base current which flow into the base. When conduction electrons, that is majority charge carriers migrating from n-type emitter, recombine with the holes, that is majority charge carriers of p-type base, in that case base current IB will be produced. IE is the emitter current which will appear as IB and IC in NPN transistor, and here emitter current IE generated from n-type emitter will appear as base current IB and IC. That's why we can say that emitter current IE will be equal to the sum of base current IB and the collector current IC. That means IE is equal to IB plus IC. Here IE is equal to IB plus IC. That is emitter current. That means emitter current IE is the cause and base current IB and collector current IC are the results. Now we can draw the symbol of NPN transistor. We can draw a symbol of NPN transistor. This is the base, B is the base, and two oblique plates, two oblique straight lines will be denoted by emitter and collector. Here B is the base, C is the collector, and here we can denote the emitter E, and emitter E emits majority charge carriers. Emitter will be forward biased. This is NPN transistor, and emitter will be forward biased by connecting negative plate of the battery to N-type emitter. VB is the battery, or VEB is the EMF of the external battery, which is connected to emitter and base circuit to provide forward biasing, and E is the emitter, C is the collector terminal, and collector C will be reverse biased, and emitter E is always forward biased. Emitter E is forward biased by connecting an external battery VEB with respect to the base. Similarly, collector C will be reverse biased by connecting a strong battery of EMF VCB. VCB is the EMF of external battery, and which will be connected to the collector and base to provide reverse biasing. This is NPN transistor, in which emitter will be forward biased with respect to base and collector will be reverse biased with respect to base. And EMF of the battery providing the reverse biasing to collector, that is VCB, will be much greater than VEB. Now we can denote an arrow on the emitter, and this arrow is denoted by red color, and this arrow denoted in the emitter indicates the direction of flow of emitter current. This arrow indicates the direction of emitter current, and as this arrow is flowing away from the emitter, that's why emitter current IE is also flowing away from the N-type emitter, and here the collector current IC and IB flow into the collector and base respectively. When majority charge carriers, that is the conduction electrons from the N-type emitter, when the conduction electrons, that is the majority charge carriers, from N-type emitter migrate, that is enter, when the conduction electrons, that is the majority charge carriers from the emitter E, enter the p-type base, comma, few conduction electrons, almost 5% of conduction electrons migrating from emitter will neutralize the holes, that is majority charge carriers coming from the emitter will neutralize the majority charge carriers of p-type base. Few conduction electrons under bracket 5% will neutralize the holes under bracket majority charge carriers in the base, which will produce base current IB, which produces the base current IB, Therefore, IB is equal to 5% of IE. Therefore, IB is equal to 0.05 times of IE. Base current IB is equal to 0.05 times of emitter current IE. IB is equal to 0.05 IE, which is the base current. Conduction electrons, that is majority charge carriers of n-type emitter, will migrate into the collector through the base, and 95% will migrate into the collector, and remaining 5% will neutralize the holes of p-type base, producing base current IB. Base current IB flows into the p-type base, Here, out of 100 conduction electrons, 95% of conduction electrons will migrate into collector from emitter through the base, and remaining 5%, the remaining 5% will remain in will neutralize the holes of p-type base. So we can say that the remaining 95% of conduction electrons pass over to the collector. 5% of conduction electrons will neutralize the holes of p-type base, and the remaining 95% of conduction electrons coming from the emitter pass over to the collector from the emitter through the base, producing the collector current. Remaining 95% of conduction electrons pass over to the collector from the emitter through the base, producing the collector current IC, which flows into the n-type collector. That's why IC is equal to 0.95 IE. Collector current IC is numerically equal to 0.95 times of emitter current IE. This is n-type emitter, then p-type base, and longest part of the transistor is n-type collector. So E is the emitter, B is the base, C is the collector. And here these dots means conduction electrons as majority charge carriers. Circle plus sign means holes are the majority charge carriers in n-type emitter. Now we can denote the majority charge carriers of p-type base. Holes, that is circled positive sign, are the majority charge carriers. On the right hand side, in n-type collector, you can denote conduction electrons as majority charge carriers, and holes are minority charge carriers. Out of 100 conduction electrons, 5% will neutralize the holes of the base, and remaining 95% will migrate into the n-type collector. As 5% of conduction electrons coming from emitter neutralize the holes of p-type base, that's why IB is equal to 0.05 times of IE, and remaining 95% will migrate into collector, producing the collector current IC. That's why IC is equal to 0.95 times of IE. So finally we can say that IB plus IC is equal to 0.05 times of IE plus 0.95 times of IE. Therefore IB plus IC is equal to IE. That means sum of base current and collector current is equal to the emitter current IE. Now we can consider the symbol of NPN transistor. The arrow sign on the emitter of NPN transistor indicates, that is, this arrow on the emitter of the NPN transistor indicates the direction of flow of emitter current with respect to the NPN transistor. The arrow sign on the emitter for NPN transistor indicates the direction of flow of emitter current.